It took me 5 hours trying to install Axolotl using pip, conda, and UV on a HPC system, and I still got the build failures and the installation failures. So if you are in a similar situation, the short version, the TLDR version of it, is that stop trying to installing things with pip and or conda or UV, and look into the containerization solution that your system provides. For example, if you're in a system, HPC system, like myself, try to use Apptainer. There's a chance that your system provides that, or if you're in other systems, or if you have access to Docker, try to install or use Axolotl using Docker. So recently I wanted to fine-tune Llama 3.2 model, and for that I wanted to use Axolotl library. And Axolotl, if you don't know, it's basically an open source LLM fine-tuning framework, and the problem mainly was that I had to work in a HPC environment. So these environments usually are shared among many users, for example, hundreds or thousands of them. And of course, it would be really chaotic. So it would be chaotic if everyone wanted to just install their own application or their own software. So they apply restrictions so that you can't really install anything on a system level. Of course, they help and they guide you towards installing packages for your research and your projects, but in general, you're not as free as you are in your own machine, of course. So to that end, I wanted to install Axolotl on HPC, the resources that were provided by NHR at FAU. Also a quick introduction. Basically, NHR is an organization in Germany funded by the government that allows the researchers to get access to computing resources. I personally, since I am a student at FAU at the moment, I have access to the resources available at NHR at FAU. So this workflow or the fine-tuning that I tried to apply on the LLM model was using these resources. And as I said, there's a restriction, and the containerization solution for our HPC is Apptainer, also previously known as Singularity. I also wrote a blog post, so if you're interested, you can also check the description and read through it yourself, or if you're interested in looking into the commands and so. So as I said, this .zip file is important for you to be able to use the container or run the container on an HPC environment. And I also wrote down the commands here. So for example, simply you can just use Apptainer pool and then the Docker image. That this Docker image was also, of course, provided by the official documentation of Axolotl, and then this command will just create an axolotl.zip file, and then you can just execute it. And this command is basically, if you run it successfully, you can be sure that everything went smoothly, and you can go ahead and just use this to train your model. Also, of course, if your system has Docker, or like you have access to Docker, you can also obviously check the documentation. They have this Docker section that they go describe how what to do, or like how to use Docker. So basically, up until this point, this is the solution. So simply use containers, use Docker, use Apptainer. And now this is the part that I also tried. Of course, first I tried to install it with a typical approach using pip, conda, and UV. And I also, of course, asked the AI assistants, like 4 of them, to solve the build error, or like try to give me a sequential approach to install the Axolotl, also with the flash attention. So all of this failed. Basically, I also tried like different installation orders. For example, if you should install PyTorch first and then flash attention, like these sort of like back and forth multiple orderings, and also multiple CUDA versions. But in the end, like it didn't work. Basically, it just ran into the problem. For example, you can also see here that I allocated a node with 16 CPUs, and as you can see here, like during the installation period, that basically I tried to install it, and afterward it just again ran into error. You can see that the CPUs were like fully consumed, and basically it can show you that the installation kind of got stuck and it didn't move forward. Also, a quick hint that if you ever try to install something really heavy, like a library that requires many CPU power for installation, make sure to allocate your own node, because if you, for example, on a typical HPC environment, you have these login nodes that you basically log into these login nodes, and then you request the compute node. And if you try to install your packages on logging node, and if it's CPU intensive or like resource intensive, there's a chance that like separately from the system, your process for like your installation process would be killed, because you are using too much resources, and these login nodes are not for heavy computation. And if you want to install something really heavy, or like you think that it requires much resources, you have to get your own compute nodes, otherwise you definitely will run into problems. And then as you can see, there was a high CPU load, and in the end it also ran into the error. So short version, basically the lessons learned is that if you want to install these sort of packages, and also I have to mention that the problem is not Axolotl, it's just the whole ecosystem of basically the combination of HPC environment and the framework, that it needs specific build versions, specific CUDA versions, and all of these things kind of contributed to the fact that in the end, like it didn't build. And also the process is really kind of confusing, because you don't have any idea what's wrong or how we can solve things, because it's just an error message, and also debugging it is usually not that fun. So the lesson that I personally learned is that to always try to use the containerization solution. Of course, before, for example, for installing VLLM, I also ran into some build problems, but after a couple of times trying to install it in different ways, I managed to do it. But for Axolotl, I could not even do this. So if you try to install a library, if you run into build problems or like anything, please be aware that there's a high chance that your system, for example, either it's HPC or any other system, they provide a solution for running containers, and try to use that instead of using the pip or like conda or like UV for installing the package or the framework directly. That being said, if you have any problems utilizing your resources, for example GPU, or you have problem with running an application on a such system, either it can be HPC or like cloud or anything, and basically if you need help with anything, I'm interested to have a look and may be able to exchange experience and have a deeper look at it. You can also contact me by the ways provided, and you can easily find it on my channel page. And if you're interested, just write me a message. And with that said, have a nice day. Hopefully I see you on the next video.